All right, guys. Sorry about not being able to be in my classroom for this next lesson. Not a big deal though, because most of it's to be done on the calculator, so it's mainly a calculator exercise. Hopefully everybody did well with the quiz the other day, and you're okay with section 7.1 through 7.3. And again, what we were trying to do in those sections was to solve systems of equations using our methods of substitution, elimination, even if it got to a system where there was 3 equations, 3 unknowns. So you can see the title of this section is Matrices and Systems of Equations. So matrices is just the plural of the word matrix. And basically what we're going to do here is take some liberties. We're going to do some shortcut and use matrices, our calculator, and the ability of the calculator to solve large systems. So you would use this for 3 equations, 3 unknowns, and beyond, like 4 equations, 4 unknowns, and so on. You would use your old algebra ways to do if it's just 2 equations, 2 unknowns. So think of this as like a streamlined technique in the same way that synthetic division was a streamlined way of doing long division. And there's a lot of similarities to that. What we're basically going to do is take a system and rewrite it in a format that is a matrix. Now, when you rewrite it as a matrix, you basically strip all the variables out of the problem, like synthetic division. When you do it, make sure that you copy down the numbers correctly, you fill in any gaps that are missing and put in a 0 in the place. So here's what we do in this problem. We would rewrite this matrix as 3, 2, -1, 4 for row number 1, 5, -3, 0, important to do that, -2 for the second row, and then -1, 5, -3, and 6 for the third row. So you can see it's basically the same problem, it's just rewritten without the variables. And you can see a faint line here that kind of separates your coefficients from your equations, and then the answers on the other side, and that'll be important when we get to using our calculator. So that's basically what a matrix is. Notice that there are brackets around it. You use sort of curly Q brackets when you were doing a system, but we put square brackets around both sides when you're doing a matrix. Again, remember to fill in the zeros and make sure that anytime there's a negative that you enter it as a negative as well. Okay? The first and most important thing about a matrix is to know what the dimensions are. Okay, so the dimensions of a matrix is basically how tall and how wide it is. So the horizontals are called the rows, and then the verticals are called the columns. So when we are determining what the dimensions of a matrix are, you multiply the number of rows by the number of columns, and it has to be in that order. So make sure that you always give rows first, columns second. So here you can see there's 2 rows and there's 3 columns. So this would be a 2 by 3 matrix. This next one, obviously, you can see is 3 rows with 2 columns. So that would be a 3 by 2. And this last one, you can see 3 rows with 1, 2, 3, 4 columns. So that would be a 3 by 4 matrix. So that could obviously be a question on a quiz. It's also fundamental, so when we go to enter it into our calculators, we know what size of matrix to put in. So again, it's got to be rows times columns. So it's always the horizontal first, the vertical second. Okay, moving on. There are numerous operations that we can do with matrices. There's 4 or 5 sections dedicated to this in the book. We're going to condense this. We're only going to do really one thing with matrices, and that's kind of solve the systems that we've been doing, or larger systems using matrices. Okay, and we're going to use our calculators to do this. If we had more time, obviously, and if this was something we could expand upon, I would show you how to do this with pencil, paper, and brain using what they call elementary row operations, and we'd either try to put it into row echelon form first and then reduced row echelon form second. But considering the systems are getting to the point where technology would be advantageous and we want to use that, we're going to use our calculators to do anything that gets to be 3 by 4, like we've been doing, and then we'll use it for bigger systems, and you'll see the power of the technology when we do that. So again, if we're going to rewrite as a matrix, what we're basically rewriting it as is an augmented matrix. Okay, an augmented matrix consists of two things: all the coefficients of the variables, so that's the coefficient matrix, and then the constant matrix, which is basically the answers. So again, another practice here, we would rewrite this as 4, 1, negative 3, 11, 2, negative 3, 2, 9, and then the last one would be 1, 1, 1, negative 3. Now it's up to you, but a lot of people like to put sort of a dashed line here to separate what they call the coefficient matrix from what's called the constant matrix. And again, coefficient matrix and constant matrix together make up a augmented matrix. And again, this would be a 3 by 4 system because again, it has 1, 2, 3 rows, 1, 2, 3, 4 columns. You do include the constant matrix when you're counting up the number of columns. Again, as I said, if we had more time, I'd show you how to do this with paper, pencil, and brain, but we've got other things we want to get to this year before the end of the year, so we're going to use our calculator to try to solve this and get an answer for X, Y, and Z. Again, the key phrases are row echelon form. That's sort of the first step, but eventually we'd like to get it into reduced row echelon form. Our calculator will be able to do this and in essence give us the answer to this system if it has one. RREF, most calculators TI-84 are going to use lowercase. Again, RREF stands for reduced row echelon form. That's going to be the key math feature that we want to use from our calculator. Keep in mind, just like in the past, there are going to be 3 possible solution sets. You know, we've solved these before, and you've come up with one solution. Sometimes you had no solution, and sometimes you had infinite solutions. So even though we're using our calculators, that doesn't eliminate those possibilities. You could still get 3 different possibilities, okay? And again, even though you're using your calculator, you still have to know how to enter this into your calculator. You have to know how to interpret your answer. It's not going to be where it just spits it out for you. So make sure you practice a lot on your calculator. I know I have to do it every year. Even though I do it once a year, I have to kind of practice with it from time to time. So what are those 3 possible solution sets? Once we get it into reduced row echelon form from our calculator, there's going to be 3 possibilities. And these are just examples, so don't take this literally. But if the system does have a unique solution, you know, one point of intersection, what you're going to see is the calculator is able to put it in reduced row echelon form. I'm using a 3 by 4 as an example here. So you can see that in the coefficient matrix, you have 1s down the diagonal and all the other entries are 0s. That means it was successful in putting it in reduced row echelon form. It means that it has solved the equation for X, Y, and Z, and the answers are over here, okay? So if it's able to do this, put it in reduced row echelon form, you'll only have 1s down the diagonal of the coefficient matrix and nothing else other than 0s in the entries. And then, of course, your answers will be in the what they call the constant matrix. So this would imply that X equals negative 3, Y equals 2, and Z equals 7. So you could write that as a unique solution, one answer here, all 3 of these equations reduced to where they intersected in one point. Okay, the 2 other situations, no solution and infinite solutions, the calculator is just not going to be successful in putting it into reduced row echelon form. It's going to try to get 1s down the diagonals, but something's going to happen and make it impossible for it to do it. If you ever get a situation where you get a row where you get all 0s in the coefficient matrix, but then a number in the constant matrix, that's just like the past. This is implying that 0z equals 7 or 0 equals 7. And again, just like in the past when we were doing it without the calculator or matrices, you had to say, oh, that's a contradiction. 0 can't equal 7, so this is a no solution problem. The alternative, and again, these are the rarities. Usually we're going to get this, but this happens from time to time. You might get a situation where the calculator tries to put it in reduced row echelon form and you get a row of all 0s. Okay? And again, it doesn't matter where these rows happen, okay? But if you get a row of all 0s, that means Well, the final row is implying that 0z equals 0, or 0 equals 0, which has happened to you before, and that implies that it's an identity. And when you have an identity, that means you have infinite solutions. So in this case, you have to, as we've done in the past, you got to let z equal some other variable. If you want z to be z, that's fine. So if z equals a, then from the second row, y plus 6z equals 3, so I replace the z with an a, and I get a representation for what y is, 3 minus 6a. Then you go back to the first row. This implies that x minus y minus z equals 1. Substitute in 3 minus 6a for y, and substitute in a for z, and solve it quickly, and you'll get that x equals 4 minus 5a. So the representation of the answer is that if you let z equal a, then y would be this and x would be this. So there is infinite solutions, and any number you plug in for a would give you another solution to this problem. And this is something that I think all of us need to work on a little bit, is how do you represent the infinite solutions to a system of equations. Okay? So obviously what we want to do now is figure out how to use our calculator. Okay? And I'm going to kind of go through it here, and then I'll put the calculator down, and maybe you can follow me do one. But you have to access the matrix menu, and the way to do that is to hit second function, x to the negative 1. You'll see the word matrix written in blue above this button, and that's how you get into the matrix menu. Once you're in the matrix menu, you can see the options across the top. It says names, math, and edit. Name is obviously just A, B, C, D, and that's how you know which matrix you're working with. Math and edit are the features where you can do things with a matrix. Okay, the first thing you have to do is enter a matrix in. So entering a matrix in, you're going to go to the edit feature. And my suggestion to you would be to set up two matrices, because the two size matrices we'll be using this the most for are a 3x4 and a 4x5. So the cursor will be prompting you to enter numbers, and every time you enter a number, just hit enter, and it moves you over to the next slot. So entering a 3x4 matrix as option A, and maybe a 4x4 for option B. I'll take you through an example of how to do it for option A. Again, as you enter the numbers, you just keep forwarding yourself, and it'll skip down a line each time you go down to the next row. After you get a matrix entered, I would suggest that you hit second mode to quit. And that kind of says I've got my matrix entered. Then go back to the matrix menu, and here's the key. We're going to go back to the matrix menu, and instead of using the edit feature across the top, we'll scroll one to the right, and we'll activate the math menu. In that math menu, there's, again, probably 15 different things you can do with a matrix. And again, if we were studying matrices a little more in depth, we would look at a lot of these options, but we're going to just explore one math option, and that is the RREF. We're going to try to put the matrix in reduced row echelon form. And now on most TI-84s, and I think maybe all, it's option B. So you either have to scroll down a lot or maybe scroll up about 3 or 4, and you want to get to option B and hit enter, and it'll go back to your screen and it'll say RREF, sort of like this. You then have to go hit second function matrix and enter in the one that you want to put in RREF, reduced row echelon form. So I know it's a lot of steps here, and it's kind of one of those things you just have to practice in order to be successful. Okay? So hopefully you'll be able to see this on the calculator. Obviously there's notes that I'll be posting as well that kind of take you through it, but maybe you can follow along with me with one example. And we will use the example that we had today to do it. Okay, so with your calculator on, obviously, go ahead and hit second function, matrix. Okay, and that gets you into the matrix menu. Scroll over to edit and hit enter. Okay, and you can see it's prompting you what size matrix do you want to do. So I'm going to use our example from our notes today. I'm going to do a 3, enter 4, so a 3x4 matrix. And if you look back here, you can see a matrix where I'm going to enter 4, 1, -3, 11 for the first row. Again, make sure you use the negative sign, not the subtraction sign when you're entering. In the second one, it's 2, -3, 2, 9. And for the last row, it was 1, 1, 1, and -3. Okay? So that's, if you remember, that's this one here that we were working on earlier, that we had this, and we put it into this coefficient matrix. So basically what we've done is we've entered this into our calculator. Okay, and there's obviously other ways to do this, but my suggestion would be to do second function, quit. Okay, so now you've got your matrix entered, so go back to the matrix menu, and this time say that you want to do some math on that matrix. Okay, and again, you can see all kinds of options here. I scroll up to option B, and you can see option A right above it is row echelon form, which is okay, but it's not nearly as good as reduced row echelon form. And go ahead and hit enter, and you can see the calculator is asking you, okay, well, which matrix do you want me to do reduced row echelon form on? So go back to matrix, choose enter A, okay, and watch how powerful this is. You're gonna hit, calculator has now put it in reduced row echelon form, and you can see it was successful because you got ones down the diagonal. So it now can tell you that, as we read before, x equals 2, y equals -3, and z equals -2. Okay? I encourage you to take a lot of these systems from previous homeworks that you knew you had answers on, or even previous comprehension quizzes, and just try them. Just practice over and over with your calculator, putting matrices in and putting them in reduced row echelon form. Now you can work exclusively with matrix A and just keep changing matrix A every time you do it. Or like I said, you could have matrix A be a 3x4, have matrix B be a 4x5, and then just access those two. Those are going to be the two most common size matrices we use our calculators for. Of course, you can do it for any size matrix, but those are going to be the most common ones. So hopefully that helps you get started on how to use the calculator. And again, just practice this. Get problems that you know the answers to, odd answers in the book, practice with those and see if you can successfully get your calculator to put it into reduced row echelon form and get the answer. Don't forget that in certain situations you're going to get the oddballs, and you have to be able to interpret those situations to give me the answers of either no solution or infinite solutions, and then represent the solutions. All right, best of luck with that. We'll take a comprehension quiz on that next week.